Mysterious lightning bursts. Some lightning are more deadly than others. If you've ever been caught in a thunderstorm and dared to look up at the sky, you know that lightning can take on a variety of scary forms. But it's not just about appearances. Some types of lightning are also more harmful than others. A new study has discovered the secret of giant jet lightning bursts that rise miles into space. Today we are going to see 3D mysterious lightning bursts that rose miles away. Watch till the end to see what this mysterious lightning is and why it's going upward into space. A detailed 3D study of a massive electrical discharge that rose 50 miles into space above an Oklahoma thunderstorm revealed new information about the elusive atmospheric phenomenon known as gigantic jets. Instead of striking down toward the ground or zipping sideways between clouds, this lightning bolt does something unexpected. It strikes the sky. The Oklahoma discharge carried 100 times the electrical charge of a typical thunderstorm lightning bolt, making it the most powerful gigantic jet studied thus far. They are the most rare and powerful type of lightning, occurring as few as 1,000 times per year, and scientists have just discovered the single most powerful gigantic jet yet. Gigantic jets are simply luminous beams that form alongside regular lightning bolts but are directed in the opposite direction. They are, however, far more powerful than their downward-facing counterparts, and can sometimes threaten space vehicles or other technologies floating in our planet's orbit. And this one was particularly intense. Scientists have identified several of these strange forces over the last 2 decades, but many of those sightings were unintentional catches from the public. In a study published on August 3rd in the journal Science Advances, researchers examined on the structure and cause of massive jet that shot out of a cloud over Oklahoma in 2018. The team discovered that the bolt moved approximately 300 columns of energy from the top of the cloud to the lower ionosphere, the layer of charged particles that separates Earth's upper atmosphere from the vacuum of space, or roughly 60 times the output of a typical lightning bolt, by studying the jet's radio wave emissions using satellite and radar data. Capturing such detailed data on a massive bolt of lightning requires an equally massive stroke of luck. On May 14, 2018, a citizen scientist in Holly, Texas, used a low-light camera to capture the jet as it shot out of a cloud top before colliding with charging particles in the ionosphere 60 miles, about 96 kilometers, above the ground. Scientists analyzing the video discovered that the jet happened to pass very close to the center of a large lightning mapping array, LMA, a network of ground-based radio antennas used to locate the area in times of lightning strikes. The plane was also within range of several weather radar systems and a weather satellite network. This upward discharge included both relatively cool 200 degrees Celsius plasma streamers and very hot, more than 4,400 degrees Celsius structures called leaders. The mystery surrounding this lightning burst rivals that of bizarre phenomena such as ball lightning. Ball lightning appears exactly how it sounds, and almost no other type of lightning is as mysterious. People have reported seeing slowly rotating balls of light, often the size of a grapefruit, floating above the ground during electrical storms for centuries. According to Levi Boggs, a research scientist at the Georgia Tech Research Institute, GTRI, and the paper's corresponding author, they were able to map this gigantic jet in 3 dimensions with really high-quality data. They were able to see very high-frequency sources above the cloud top for the first time with this level of detail. The researchers studied the size, shape, and energy output of the massive jet in unprecedented detail using these sources combined. They also said they were able to determine the location of the very hot leader portion of the discharge above the cloud using satellite and radar data. Scientists studying a thunderstorm in Oklahoma discovered that its electrical discharge was 100 times stronger than that of a typical lightning bolt, shedding new light on this rare atmospheric phenomenon. The researchers had suspected very high frequency and optical signals, but it is not proven yet. The very high-frequency radio from lightning is emitted by small structures known as streamers at the very tip of the developing lightning. while the strongest electrical current flows significantly behind this tip in an electrically conducting channel known as a leader. Lightning bolts are created by a combination of leaders and streamers. Leaders are the result of electrical charge differences that aid in the development of lightning, and streamers are found at the very tip of those developing bolts. These forces collaborate to spread electricity channeled from within the stormy cloud, but leaders typically form the majority of the discharge. Steve Coomer, a Duke professor of electrical and computer engineering, studied the powerful phenomenon using electromagnetic waves emitted by lightning. He runs a research facility where conventional antenna-like sensors are arrayed in an otherwise empty field, waiting to pick up signals from locally occurring storms. Doug Mock, a co-author of the paper at the University Space Research Association, said the study was unique in determining that the 3D locations for the lightning's optical emissions were well above the cloud tops. The fact that the massive jet was detected by several systems, including the Lightning Mapping Array and 2 geostationary optical lighting instruments, was a one-of-a-kind event that provides us with a wealth of new information about massive jets. This is probably the first time a gigantic jet has been three-dimensionally mapped above the clouds with the geostationary lighting mapper. So why does lighting sometimes blast upward instead of downward? Scientists are still unsure, but most likely involves some sort of blockage that prevents lightning from escaping through the bottom of a cloud. Massive jets are typically observed in storms with few cloud-to-ground lightning strikes. The team said there is usually a suppression of cloud-to-ground discharges for whatever reason. In absence of the normal lightning discharges, the massive jet may relieve the buildup of excess negative charge in the cloud. The team also noted that massive jets are most commonly reported in tropical regions. This adds to the awe of the record-breaking jet over Oklahoma, which was not part of a tropical storm system. More research and a lot of luck are required to comprehend these epic, upside-down events. For example, a violet streak was photographed from an airplane flying over Bhadrak, India, and another was captured with a nighttime camera near the 6,240-foot summit of China's Shukingkong Mountain. NASA added an experiment to the International Space Station in 2013 to help us get a better, more actively placed look at the scene above cloud tops so we can catch gigantic jets in action. Nonetheless, the scientific community lacks many observing systems tailored to this search. A better understanding of gigantic jets will not only help scientists better understand the electrical properties of storms and the jets themselves, but it may also provide important information for the operators of the growing number of low Earth orbit satellites, which may be put at risk by these massive lightning bolts to space. This gigantic jet is one of the rare and powerful types of lightning. In an average year, only 5 of these jets are observed. Weather satellites occasionally spot them, and lucky photographers capture them in long exposure images. And with that, here comes the end of the video. These lightning are very rare and we are lucky to see them. What's your thoughts on this? Let us know in the comments. If you really liked the video, don't forget to like the video and subscribe to our channel. Goodbye for now, and see you in the next one.